Okay, so it's my first time here. It's a great pleasure. And what I'll be talking about today is not the mind, though, but the brain and different brain areas. But hopefully, it will be. I mean, I will make it as easy as possible for you guys. So I won't be talking in details about different functional areas, except for the thing that I will mention here. So there are basically, what I will be talking about is skilled actions, which learned movements that are often referred to as praxis, and language. So at first I will introduce some of the left hemisphere regions that are being involved in the control of these skills. So first of all, maybe the inferior frontal gyrus would be one of the most important for language production, for example, but also for recognition of action. So yes, this yellow thing here. Then the supramarginal gyrus. This is an interesting place in the brain because when you have it damaged, typically in the left hemisphere, damage affects both of the hands. So you may think that the right hand is controlled by the left hemisphere and the left hand by the right hemisphere. But for skilled actions, for higher order actions, when you have the supramarginal gyrus damaged, it does affect your performance with the left hand. And there are a few other areas like the caudal middle temporal gyrus, which has been repeatedly linked to action concepts. And, for example, the ventral premotor cortex, which is very often related to planning and execution of actions, monitoring actions and stuff. So, in general, organization of movement kinematics. So, I mentioned the left hemisphere, and the left hemisphere is very often kind of discussed in the context of apraxia. Apraxia being difficulties with tool use primarily, but any skilled actions, including intransitive gestures such as waving hello, goodbye, come here, go away, this kind of stuff. And I won't be spending lots of time on these issues here, except for mentioning that there are many different studies at some point to different areas that might be involved in the control or in when damaged. There are reports demonstrating that different kind of deficits are being present. And even though some of these reports seem to be contradictory, it looks like everything, in part, everything depends on the task that is being performed and also, what kind of damage there is. So, for example, Kathleen Halland reported that for guys who have problems with showing how to use tools, so plan and then execute tool use gestures, the most critical areas were middle frontal gyrus and the vicinity of the intraparietal sulcus. But she was primarily looking in her research for maximal lesion overlap for those guys who have these problems. On the other hand, Georg Goldenberg, he claims that the most important areas in apraxia, tool use problems, is the inferior frontal gyrus, but he was actually looking for the maximum difference between lesions in those guys who have tool use skills affected versus those guys who have lesions, still have lesions in the brain, but tool use seems to be intact in their brains. Okay, and I'll skip the rest. So there are also many other reports, and they consistently point to one fact that, basically tool use pantomimes are more affected by left hemisphere damage as opposed to intransitive gestures. And even if the guy has a problem with showing how to use a hammer, when given a hammer, for example, performance is very often way better. And finally, what I would like to say is that there are also reports that intransitive, the more communicative gestures are also affected, but these are, the reports are less often and the problem is kind of milder. Okay, there are also fMRI studies and using different paradigms, and I won't be talking about these paradigms here, but what I would like to mention is that all these, well, the majority of these reports show the following thing. When you compare, for example, the ability to perform tool use gestures as opposed to other hand movements which are not gesture related, it is primarily the left hemisphere that is being involved. Oh, this is not what I wanted to do. I apologize. The left hemisphere in all these reports, whether block designs are used or some kind of event-related designs, you will learn about these later on a little bit. It is the left hemisphere that is being primarily involved in the control of tool use pantomimes or tool use gestures, as well as intransitive gestures. So what I would like to say is the following. When I came to this area, I realized very quickly that even though there were these reports of problems with intransitive and transitive gestures, and people claimed that they might be represented different, that two gesture categories might be represented differently in the brain, there were some problems with the reports because, well, primarily the pattern that emerged was that tool use gestures were most often affected by the left hemisphere damage, but not necessarily intransitive gestures. And there are cases, at least two very famous reports that, you know, like there was a complete preservation of the ability to perform communicative gesture after massive left hemisphere lesion, which suggested, at least to some people, that communicative gestures must be at least in part or primarily represented in the right hemisphere as opposed to the left hemisphere, which seems to be involved primarily in the control of tool use pantomimes. So there was such a claim. But no clear double dissociation between these two skills have been reported. So I thought this was a very good way to start. I mean, before I started running this study with Scott Fry from the university, back then at the University of Oregon, I was more working on the simple visual control of grasping, movement, and reaching, and then gradually moved to this area. And this was one of the first studies that I did in the area of gesture. And so basically what we did with Scott Fry was we ran an event-related design, which is the following. So on the screen, there is a word being presented such as, for example, dialing, pounding, painting, typing, which these words are related to tool use, or beckoning, hitchhiking, you name it. And so these words were presented for a second and a half. Then there was a delay interval. From this moment on, the participants were to plan the gesture, and then when the green circle appeared on the screen, they were to execute it. And there was, of course, afterwards, there was some interstimulus interval. And of course, we also wanted to control for language processing. So look, there is one thing. People talk that gestures are controlled by the left hemisphere, but there might be a confound. Language is also controlled by the left hemisphere. So what we had is a good control task in which there was also a word such as adapting, being, understanding, that has no gesture associated with it. So people read it and then abandoned any plan to kind of perform any movements. Okay, so basically what we noticed is, and what I'm showing is the following. Here are the data for the right hand, here for the left hand, and this is actually planning tool use here. Planning tool use after all the linguistic component is being extracted from the activity. And note that what is being activated for planning tool use is primarily the left hemisphere, although there is some involvement of the right hemisphere. look now, as far as intransitive gestures are concerned, after the subtraction of all the linguistic processing, it was primarily the left hemisphere, completely inconsistent with the hypothesis that intransitive gestures might be controlled by the right hemisphere. Most of the neuropsychological reports are based on the use of the left hand because the left hemisphere is damaged, so the right hand is hemiparetic or paralyzed. It cannot be used for testing. So patients are being tested with the left hand. And what happens is, of course, the left hand seems to kind of be affected still by the left hemisphere lesion. Look what an interesting thing we found, especially for intransitive gestures. Intransitive gestures for the left hand were controlled only after all the linguistic processing was subtracted from it, seemed to be controlled primarily by the left hemisphere. But these are right-handed people. So there might be a problem of the kind that right-handed people have their language skills and gestures lateralized to the left hemisphere. And just to anticipate my study with left-handers, I'm mentioning this, but so now quick conclusions. I will skip this because this is not particularly interesting. So basically, what I was able to demonstrate with Scott Fry was that planning transitive gestures with the right hand engaged primarily the left hemisphere. I won't be mentioning all these areas. And especially after, this was the case even after the linguistic processing was subtracted from the activation. And of course, there are several areas that showed greater responses for planning tool use gestures versus intransitive. So this is kind of consistent that when you have a lesion in the left hemisphere, you may be more impaired with tool use pantomimes as opposed to intransitive gestures. And then the last thing is such that, I didn't show the slide, but when we contrasted these conditions directly, because I never showed you the direct contrast of tool use pantomimes and intransitive gestures. When we contrasted these directly, the only thing that was primarily left was the sensory motor activity in the left hemisphere for the right hand and in the right hemisphere for the left hand. And if there were some higher order areas involved, they were not in the right hemisphere for intransitive gestures. Okay, so the same thing happens for the left hand, so I can kind of skip this. Just even when the left hand is being used for the planning and then execution of tool use pantomimes and intransitive gestures, it is the left hemisphere that is being involved. But as I said, these were right-handed patients, participants, not patients. And of course, there might be an obvious confound because it may be the case that the representation of skilled movements is close to the representation of the dominant hand. Yeah? So if you are right-handed, it would be the left hemisphere that dominates, that is dominant for the control of movement in general. So it's no surprise that it also for the higher order skills like planning the movement in advance, these representations might be closer to the areas that kind of contribute to hand dominance. So we started testing left-handers. And the same paradigm, so I don't need to spend much time on this. And I will go immediately to the results. But here I'm showing first the results for the left hand. So, and note that I am no longer differentiating between tool use pantomimes and intransitive gestures because, again, I didn't see much of a difference. So I kind of combined the two gesture categories, and I'm showing the activity for planning both gesture categories versus the linguistic control in left-handers using the left hand. This is really interesting because you would expect they are left-hand dominant. It should be the right hemisphere because the right hemisphere controls hand dominance, and it is not. And it is not. It is primarily the left hemisphere. There is some activity in the right hemisphere, but it looks like all the areas that are critical for the control of skilled actions in right-handers are also involved in left-handers. The most surprising thing for me was when I saw the activity for the non-dominant right hand, because this time it should be the other way around. So the right hand being used, it should be controlled predominantly by the left hemisphere, and it's not. It's just a mess. Like both hemispheres get involved. So it was quite a surprise. And by the way, this is very simple. I mean, I know that it looks like there is a lot of activity in the right hemisphere, but this picture is not that different from actually right-handers when they are using right hand. Before we subtract all the activity that is related to language processing, in right-handers using the right hand, there is also a lot of right hemispheric involvement. Okay, I'll show you some more data. So this is the so-called hand-independent substrate. So this is what is common for both hands. And what is common for both hands is one of the critical areas is the supramarginal gyrus. And I mentioned it earlier that when you get damage there, people typically have problems with controlling gestures of different categories, irrespective of whether if they are able to use their right hand, because sometimes it is possible, whether they use their right or left hand. And this is the hand effect. So what I'm showing here is all the areas that are more active for the right as opposed to the left hand. And it again looks like a bilateral network of areas is involved. So this is kind of tricky because it's a very surprising outcome that many people kind of don't know, including me, don't know how to interpret. Okay, so let's. So I said that I collapsed across the two gesture categories, but as I said, in neuropsychological literature, there are many reports in which their patients have had problems with one type of gestures, but not with the other type of gestures. So I analyzed all my guys, all the participants, because earlier I was presenting group data. And now I'm looking at all atypical guys in this population. So what I do here is to simplify things, I look at the right and left hemisphere, regions of interest, by the way, not necessarily across the whole hemisphere, but if I looked across the whole hemisphere, it would be pretty much the same. So what I'm looking at is I identify the maximum activity in one of the hemispheres, and then start counting how many voxels, the so-called, this kind of small resolution pixels that we measure, but these are 3D, hence they are called voxels. How many voxels there are for the control, for the planning of one gesture or the other in one or of the two hemispheres. So if we get positive results, and this is praxis lateralization, so the lateralization of gestures. If we have these symbols here, this means that these are represented in the left hemisphere. If it is negative, it looks like it is in the, it looks like the right hemisphere predominates. And as you can see, there is only one guy who has like these two gesture categories differently represented in the brain. Tool-use gestures represented in the left hemisphere, but intransitive gestures in the right hemisphere, consistent with some of the neuropsychological reports that this can be the case. But in the majority of cases, it was never like that. So yeah, some of the guys had more bilateral representation of intransitive gestures, but yeah, this guy had actually more bilateral representation of transitive tool use gestures. This was for the dominant left hand. When we look at the right hand, things change. So this is a very complex thing, actually. So researchers were rarely able to test their patients with their right hand because it was hemiparetic. But if they had a possibility to test it, sometimes they could see the opposite effect. So intransitive gestures for the right hand represented primarily in the left hemisphere, but tool use gestures represented bilaterally. And actually, recently there was a paper in which such cases were also discussed. But Vesela Stamenova, she works in Toronto and works with very famous neuropsychologists, for example, Eric Roy. She finds only cases of partial dissociation. So even if intransitive gestures are affected, they are not necessarily affected when people imitate intransitive gestures as opposed to plan based on linguistic cue and vice versa. So, okay, I'll skip the next slide because this is the same data but now shown by hand, and this is not that important. So, you saw the results for right-handers, for left-handers, and now a direct comparison of right-handers and left-handers. And I would like to emphasize it one more time, that even in left-handers, the planning of both gesture categories did involve the left hemisphere. So what we are looking at here now is the difference between the two. So what is being more involved in left-handers versus right-handers? And as you can see, yes, there is a structure in the parietal lobe, the angular gyrus, to be precise, that seems to be modulated more in left-handers than in right-handers. But the interpretation is tough because this structure wasn't even involved in the planning versus baseline, which means there is modulation of this activity, perhaps some suppression, bigger suppression in right-handers, not necessarily, this does not necessarily represent activation. Okay, so this is left-handers versus right-handers for gesture planning. Let's move on and let's see gesture execution data. And no difference, left-handers versus right-handers again, no difference in the left hemisphere, which is consistent with the idea that both groups actually do engage the left hemisphere, although left-handers seem to engage some of the right hemisphere areas more. The inferior frontal gyrus, often related to language processing, is involved more in left-handers here. This activity modulation doesn't seem to be that exciting because it's primarily sensory motor, basic sensory motor processing. Okay, so this is a gesture execution for which areas are more engaged in left-handers versus right-handers, and now the opposite. So what is being more involved in right-handers versus left-handers? And now we see that, yes, there are lots of left hemispheric regions, not lesions, which are being engaged more in right-handers versus left-handers. But again, I would emphasize that it does not mean that these areas were not engaged in left-handers, but perhaps were engaged less. Okay. So I will kind of now switch gears a little bit because I emphasized the fact that gestures and language might be related. And actually, when I studied my left-handers, I actually explicitly tested this hypothesis. So is there a common cerebral specialization for language and gestures being in the right or left hemisphere? So basically, Why left-handers would be an interesting case to study? Because in the majority of guys, even in the majority of left-handers, you would see language and praxis represented in the right hemisphere. But there are atypical cases. And the most common atypical cases being people who engage more the right hemisphere for language and for gesture are among left-handers, strongly left-handed individuals. So, well, I recruited for this study really strongly left-handed individuals, hoping that at least 30% of them would have unusual lateralization of functions. And there were reports, of course, of people with atypically represented language and praxis, but these were typically related to epilepsy. So if someone had an intractable epilepsy from childhood, then it very often happened that, and it was left hemispheric, so it very often happened that the language and praxis skills were in such a person represented in the right hemisphere. But we wanted to see whether this can also happen in healthy individuals. And, by the way, there are also, this is a very nice report of 4 right-handed people who have almost every skill. I mean, whatever skill you associate with the left hemisphere, they have it reversed, and vice versa. So this is not 100% kind of flip, but pretty close. So yeah, reverse lateralization of language is possible even in right-handers. Okay, so what we did, oh, by the way, so there are reports. So what I'm showing here is, I know that you probably cannot see it well from behind, there, but this is handedness. So here we have right-handed people, here left-handed people, and this is their language dominance. So right-handed people have their language skills primarily represented in the left hemisphere. And left-handed people, also, the majority of them have language skills represented in the left hemisphere, but there is a higher incidence of atypical right hemispheric activity related to language in left-handers. So this is why we tested these guys. And what we did, hypothesis, I basically mentioned it, so I will skip them quickly. So I was hoping that praxis and language might be related, and the most interesting cases would be the ones in which language is in the right hemisphere, and then we would see, so if language is in the right hemisphere, what happens with praxis? Yeah? Okay, so I'll skip this because, yeah, I kind of alluded to these already. So we used a very, very simple paradigm for testing language in the fMRI scanner, being a simple block design. For 30 seconds, people saw a letter on the screen, and they were asked to generate as many words as possible starting from this letter. Then there was a period of rest, and 30 seconds, and then after these passed, another letter was shown, and they were generating these words. This is a very kind of simple, but on the other hand, very accurate measure of language laterality, one that correlates best with all the earlier tests, including the WADA test. If there is someone in the audience who knows what the WADA test is, you know, you inject a chemical into the artery, and then one of the hemisphere becomes effectively numb for quite a while, and yeah. And using the WADA test, it has been nicely demonstrated which hemisphere is dominant for language. This is almost as good. Okay, so primarily what I'm showing here is the data for, I call it the verbal fluency test, for left-handed guys. This is group data. So at the group level, most of these guys engage the so-called Broca's area in the left hemisphere. This is why I see it at the group level, although there are some guys who seem to be engaging the right hemisphere as well. By the way, there is a structure beneath. This is called the insular cortex, and this is just a side note. This structure is way more important for language and lateralization of functions in the brain than the Broca's area. But this is not the topic. But if you ever have a chance, if you encounter the insula, pay attention to it, because this is way more important for language than the Broca's area itself. At least as far as the laterality of processing is concerned. And so what I'm showing here is this same analysis. So some of the guys criticized me. This is the whole brain analysis, but just why don't you run an analysis within the Broca's area only, and then you will see that there is lots of activity in the right hemisphere? Not necessarily. So as a group, left-handers show predominantly left hemispheric activity. Okay, so here the method is being shown how I calculate the laterality index, and basically, so what I do is, I already kind of said it, that what I do is I go to a given area, identify the voxel that is being the voxel of biggest activity, and then count how many voxels in the brain in the left and right hemisphere region of interest are activated. And so you can imagine that if there is a maximally activated voxel is in the left hemisphere Broca's area, and when I count the number of voxels activated at this level here and here, there will be nothing. Yeah? And then I do it at certain levels, set certain thresholds, and come up with an idea which hemisphere dominates here. So basically, yeah, kind of, I can skip this, and this is what I get. So primarily, this is the laterality index for gestures, for praxis, and this is for language. And without going into details, I would like to emphasize one important thing, that what hopefully can be immediately seen for you guys, and if not, I will help you. There is a clear relation. Yeah? So, when something happens with language, then obviously there is a change in the laterality of praxis. And this is particularly visible here, although I may add immediately that it is way easier to find an individual who has atypically represented gestures as opposed to a language, because I only had one individual who had kind of, at least in this sample, who had language lateralized more to the right hemisphere, but then his praxis skills were more bilateral. At any rate, there is a clear relationship. It looks like gestures and language follow each other in the way how they are represented in the two hemispheres. Okay, so yeah, this is kind of, I said what this shows is that this correlation actually holds for all the, even if I consider all the gestures separately, and even if I consider the left and right hand, this correlation holds. Okay, so conclusions for now. There is a clear relationship. There is a natural variability of how these, how language and praxis are being kind of represented in the brain, and my findings and some other findings recently are consistent with the idea that this relationship actually kind of capitalizes on a common cerebral specialization. Okay, this is yet another study that actually demonstrated very well what I did in 2011. This report first appeared in 2011 anyways, but Cortex is a very slow journal. So the final publication was in 2013, and Guy Wingerhood nicely showed that if someone has language in the left hemisphere, then praxis is also in the left hemisphere. On the other hand, if someone has language in the right hemisphere, it is very likely that praxis skills will be also represented in the right hemisphere. There is yet another report which shows that symbolic gestures like the intransitive ones that I studied, and language share some areas, but, and guys, this is kind of now an important switch, but these are gestures. And we kind of always associate gestures with language. Yeah? So even if the areas that are being involved in the control of gestures are somewhat different from the ones that are involved in the control of language, well, the fact that they may share some hemispheric specialization may not be that surprising. So we went on, in my recent projects, we went on and studied more fundamental functions, such as, for example, planning functional grasps. For example, there is a tool, and you are to grasp a tool in such a way that you could use it immediately. Okay, so these are the examples of tools that we used, and control objects. Some of them were really well controlled for complexity, note, yeah. And, well, in general, they were pretty well matched. So what our participants had to do is plan functional grasps, and note that in some circumstances, the functional grasp required a very uncomfortable rotation of the hand, yeah? As opposed to when people are to grasp such a thing, they wouldn't bother. But what I'm going to show you is show the data without even this confound. So I'll show you the data in which everything was perfectly matched, so no differences in hand rotation, no differences in hand kinematics. And so I'm now interested in, this is a very basic thing, just planning a functional grasp. Would it be represented for the left hand in the right hemisphere? Okay, yeah, yeah, I still have like 3 minutes and or 4, so okay. All right, this is what has been done in event-related design, very similar to the one that I used. So picture, planning, execution, and here are the data. This will be easy. Planning functional grasp in right-handers, right hand. No surprise that the left hemisphere is being primarily involved. But what happens for the left hand? Left hand, the same areas in the left hemisphere are involved. And this, I would kind of ignore it because this is purely sensory motor, just basic motor processing and sensory motor processing. Okay, so these are right-handers. What about, oh yeah, this is a direct contrast. A direct contrast shows that in all higher order areas there is no difference between the control of the left and right hand. So just the sensory motor, which is very encouraging. Okay, left-handers. Left-handers using their left hand, left hemispheric, primarily. Left-handers using the right hand, less left hemispheric, but left hemispheric. A direct contrast shows no difference in higher order areas, but just the sensory motor things. And yes, so beautiful, but because now I would like to mention language. This is language verbal fluency test now in right-handers. Primarily left hemispheric. In left-handers, primarily left hemispheric. And the take-home message. So what I wanted to, because the idea of this talk was such. Guys, for many years, left-handers were excluded from experiments because people believed they have unusual organization of functions and stuff. Well, my research doesn't support that. No, when I run a direct contrast between left-handers and right-handers, I almost see no difference. No difference. Of course, there are individuals with atypical organization of functions, but these are in the minority. So this is, for example, a comparison of right and left-handers in language. Some kind of weird differences, not language related. Here, on the other hand, I selected atypical subjects from my sample, whether right-handed or left-handed, and show that only then there is a difference. Yeah, I'm concluding. Yes. So, guys, my take-home message would be such that right-handers and left-handers are not that different. it's true that left-handers may have a more balanced organization of functions, but the most important thing is that it is subjects with atypical lateralization of functions that may kind of be interesting, and they can be right or left-handers, and this is the most important thing. It's not left-handedness that is linked, that can be easily linked to problems with reading, stuttering, but atypical organization of functions. Yeah, and yeah, so that's it. Thank you very much. And these are guys who contributed.
Thank you very much indeed to working to some comprehensible conclusions from some very difficult experiments.
So this is a very hot topic now, particularly because of this Galezian hypothesis of language within our grasp. And Michael Arby, apparently he was in Poland talking about this idea as well. So this the notion that language parasitizes, evolved, or I don't know, reuses the same structures that evolved for gesture. So I'm trying to, because I try to see the forest, because I see a lot of truth, but I cannot see it at all. Because you seem to be saying that, at least on a correlation level, that definitely is a correlation between gesture and language localization, and that it travels the way it should travel. Okay, so and so this is very impressive correlation at 0.73. But I think you were saying that the lesion data, which are the causal data, don't actually support that strong association. So I'm trying to figure out, I'm just mocking because maybe I'm trying to figure out whether, do the fMRI data tell a different story than the lesion data about that question of localization of language and gesture? So
yeah, basically, the problem with neuropsychological data is such that they have selected cases. And for example, for left-handers, there are reports of every combination. Okay, so sometimes they find a person who has right hemispheric for language, left hemispheric for praxis. A big theory is being proposed. Then a different paper proposes a different theory based on their case. And this is probably why you can no longer publish a paper with a single case, because this should not be allowed. And in the past,
the level of generalization. So you think that there are no good lesion data right now?
Well, there are, and so I would say that this, actually, with the picture that I have, come on, maybe I should do this. Yeah, okay.
So I got it on the correlation level.
But this is actually, if I go to this graph, this is very consistent. Come on. This is very consistent because, look, this guy has been reported in a study at the University of a kind of like this has been reported. A kind of like this has also been reported. So there is no contradiction whatsoever. You see what I'm saying? Like there's this, even this model predicts that there will be exceptions to the rule. And the problem with earlier studies was that exceptions to the rule were used as the basis for the big model.
Given from 2,000 milliseconds up to 6,000
yes.
milliseconds. So the first question is, whether did you find some kind of differences whether you give 2,000 milliseconds or 6,000 milliseconds? And just try to imagine one of the gestures. And I believe I need just 1,000 milliseconds.
Yeah, this is a.
Have you used this?
Yeah. A great question. So actually, the reason why I introduced this so-called jitter is that only this helps me to disentangle the activity from planning versus execution. And what I model actually is the first 3 seconds. So a second and a half of a word plus a second and a half of a planning. Because yes, this is also my intuition that within a second or a second and a half, everything can be effectively programmed or planned, and this is exactly what I did. A great question.
Can I get another one? Because maybe this is something that philosophers are obsessed with this idea of goal-oriented actions versus non-goal-oriented action. In some sense, you're transitive versus intransitive. It doesn't completely overlap. It's kind of complicated because I think that your meaning of goal-oriented is different. But anyway, I mean that's how this is studied in psychology. But so it's stunning that you don't get any distinction between these two kinds of actions, right? Because all these theories, I mean, a lot of these, Gillespie uses a lot of it also rides on the distinction, right? That this is supposed to be the system that is specifically for goal-oriented reaction. And you don't see any evidence for this in your data.
Well, so I would say that the current take on these issues, and even neuropsychologists agree with that, is that one of the gesture categories is just simply harder, and it needs more brain resources as opposed to well-skilled intransitive gestures. So I don't think there is any problem, and they are both goal-oriented, but one is easier, so may capitalize on different networks to a degree, memory, yeah, but in general, the praxis representation network underlying them would be the same.
You have a very sharp distinction between left-handers and right-handers. Presumably some of the right-handers, even these days, are natural left-handers who've been forced to be right-handers.
Yes.
And presumably there are people who are equally happy with both. Does that affect?
Yes, we do take these distinctions into account. So what I'm presenting is only very strongly left-handed individuals, but in my study that I ran using the Maestro grant from the National Science Center Poland, I'm making a distinction between strongly right-handed individuals, strongly left-handed individuals, and individuals who are ambidextrous. And in every participant, we take many measures that let us know how skilled they are with their hands. And yes, so if you take as the kind of cue to dividing your participants the Edinburgh laterality index from the simple questionnaire, this is pretty much kind of useless unless you go further and only then differentiate how fast they are with their left and right hand, how strong their left and right hand is, and we ask them many other questions. We also have EEG. And only then, when we have the big picture and we see, okay, this guy is atypical, this one is typical. When we run, so instead of running left-handers versus right-handers, we started running analysis atypical versus typical, and only then we see fantastic differences.
One more.
Well, I'll make it very short. In response to the question about taking account of goal-directed behavior, you rightly made a connection suggested between transitive and intransitive gestures, but you seem to suggest that there was a difference only of degree of complexity and nothing very deep. Was that what you wanted to suggest? I didn't see why the distinction might not be pretty deep, but I also didn't see how it mapped onto the intransitive distinction.
Yeah, I realized that my question was not so much related to goal-directed thing, rather than how these two gesture categories relate. Well, of course, if you think about how to use a tool, you need to imagine a tool. So it is goal-direct in a sense, or the recipient object. Yeah. So you use the hammer in order to, and so this is a more complex action as opposed to come here or go away. So these are goal-directed actions, both. In one instance, you manipulate people, maybe, in a sense, yeah? Ask them to come. And in the other case, you just manipulate objects. But
where I'm really driving in a nail, there's a feedback loop as well. But you'd say that's another layer of complexity.
Yeah, but when you say this and the person approaches, there is feedback.
Yes.
So,
Thank you very much.
thank you.